Hey everybody, it's Ripley again. I'm back, and we're going to talk about section 2.8, derivatives as functions. Okay, now let me tell you what I mean by this. Remember, if I have a function, which I call f of x, and I want to figure out the slope of the line tangent at x equals a, right? There's two ways to do it. I know this is redundant, but bear with me, okay? It's important. And I got this point right here, which I'm calling, whoops, sorry guys, I'm calling a comma f of a. Then I can figure out the slope of the line tangent to the function at a very simply. There's two ways to do it. We call this f primed of a. And this is either going to be the limit as x approaches a of f of x minus f of a divided by x minus a. Or we can take the limit as h goes to 0 of f of a plus h minus f of a all over h. And they'll both give us, these both equal the slope of the line tangent. Now we know this, we've already done this. However, the problem with this is it's kind of a pain in the butt because I have to do this for every single point at x equals a. Remember when f of x equaled x squared and we found f primed of 2, right? And we figured out that that was 4. Remember, this is kind of coinkadinkle, but by now you probably see that there's a whole bunch of different derivatives. The problem is I want a formula. How about a formula for all tangents, right? Slopes. Well, watch how easy this is. What I want, instead of f primed at a, where a is known, I want f primed at x. And watch how simple this is. There's one problem, all right? As soon as I go to f primed of x, notice that this guy right here is gone. He disappears because if I try and simply, wherever I see an a, stick an x, watch what I get. I get the limit. As x approaches x, you could probably already see what's going to happen here. F of x minus f of x over x minus x. Not usable. However, this guy right here, f primed of x, is going to be super usable. If I take the limit as h goes to 0 of f of x plus h minus f of x all over h, this is my formula. This is everything. Now, let's do an example, okay? Let's do an example. So let's do it for f of x equals x squared, since we've already played with that a little bit. If I want f primed of x, then let's look at what happens. It's going to be the limit as h, not x, as h approaches 0 of, now f of x plus h, well, f of x is x squared, so f of x plus h is going to be x plus h squared, right? Makes sense. So when I multiply this out, I end up with x squared plus 2xh plus h squared. Then I have to plug in my minus f of x right here, so minus x squared all over h. Now, if you look close right here, look at what's going on. I got an x squared that goes away. I got an x squared that goes away. So now I've got the limit as h goes to 0 of 2xh plus h squared all over h. If I plug h equals 0 into this, remember, plug it in, I get 0 over 0. Bummer. However, hopefully you can see that this h goes into this h and this h. I end up with a little 1 right there, right? So I end up with the limit as h approaches 0 of 2x plus h. As h goes to 0, I get 2x. Look at that. Now, look at this guy. Let's take a gander at these on the other page. Let me show you why this is what it is. Okay, so you ready? I want to go to, I think I'm in black right now, right? Yep, perfect. Okay, so f of x is a badly drawn x squared, right? So this is f of x equals x squared, and f primed of x is 2x. So I'm going to draw this kind of badly, but work with me here. This guy right here is f prime of x, which equals 2x. Now, what do you notice here? Let me draw some little snatches of tangent lines. See these guys? At 0. Here we go. And here we go. Now look at what's happening. When f of x equals x squared, when this guy levels off, which we know it's parabolic, so we know that it does it at 0, look at what the first derivative of f of x is. It's 0. This guy right here, this f prime of x equals 2x, is a formula for all slopes of all lines tangent to f of x equals x squared. So as f of x squared starts to blow up, what do you notice about f prime of x? It gets bigger and bigger and bigger. Now look at these slopes of lines tangent. These are all negative, right? Well, guess what? Look, f of x equals 2x is negative. 2x is less than 0 when x squared is decreasing, right? X squared is decreasing, which implies that the slopes of its tangent lines are less than 0. Look at that. It's perfect. So if I want to know what f primed at -3 is, I no longer have to go through the business of the limit as x approaches -3 if da-da-da-da-da-da. Screw that. I know I've got a formula. I just take 2 times -3 and I get -6. So over here, let's change my color one more time. So over here at -3, I know that the slope of that tangent line is equal to -6. I also know that down here, this is getting hard to read, but bear with me. I also know that down here on this line, that point is -3, -6, because I used it to find the value. You dig it? That's pretty fun. Now, I want you to notice something else. The derivative, I'm going to change this awful puke colored green. It's going to drive me crazy. The other thing that's really important to understand here is that the derivative, f prime of x, is also a function. Now, there's lots of ways to prove this, but the simplest is to simply look at the definition. The limit as h approaches 0 of f of x plus h minus f of x all over h. Look, I've got a limit of a function minus a limit of a function, right? So if I do that, then I'm taking a limit and then I'm just dividing by a constant. These are both functions, so it's got to be a function, all right? So think about that. That is so cool. If f prime of x is also a function, then whatever we did to f of x, we can do to f prime of x. But we're getting a little bit ahead of ourselves.